So at the end, what we get here a table with the windows, the list of windows. In the columns correspond to actions of the system that have been reported. The last column is the class with a 0, which means that no intrusion objective has been observed. 1 corresponds to identification of the intrusion objective that has been observed, etc. So we get something that can be used for classification purpose. So we transform the set of alert to a table such that we can use it easily for learning step. I don't know if it's clear or... So the first step is just you have set of alert, we get a table. Why we get a table? Because we can easily learn. And here we see that we will learn intrusion objectives on the basis of reported actions. This is exactly our aim. Our aim is to predict, given some reported actions, whether some intrusion objective will be reached or not. So we built a table that allows us to learn this. So this is the first step. It just transforms a set of alert to a set of formatted data. Now the second step is to learn naive Bayes. The structure is fixed. We can use more complex structure like TAN, for instance, tree augmented naive Bayes. But the performance, there is no big differences in performance. And we compute parameters. Parameters simply means conditional probabilities, a priori conditional probabilities, and we use Laplace estimator. So the last step is to predict, and we predict exactly online. We simulated something that will be used online. Namely, each time that you receive an action, you will take the node corresponding to this action. You will let the evidence, namely this action has been observed. Then you propagate. You make some probability propagation, which by the way is done in linear time, which is namely very, very efficient. Then you compute the new probability distribution of the class. This is exactly these two steps. First, you update your network to saying that the value of this action is true because it is reported. Then, after that, you propagate and you compute the new probability of the classes. And the objective of inference is given observed node. Observed nodes means alerts, actions that have been reported, to estimate the value of hidden nodes. Hidden nodes here is a class. So we use one naive Bayes for each objective intrusion. Why one naive Bayes for each intrusion objective? Because the same actions may concern several intrusion objectives. Namely, one may have, given some actions that has been observed, the probability of some O1, for instance, DDoS 1 is equal to 1, and the probability of DDoS 2 is equal to 1. If we just use one naive Bayes for the whole set of objective intrusion, unfortunately we cannot represent this. We will just simply half and half. Of course, you can use the most plausible or what you like. But it's better to use one naive Bayes for each objective intrusions, because when it's one, there is no ambiguity. It means that the intrusion objective has been reached. Then the prediction inference computes new probabilities for each intrusion objective. It's very easy. It's done in linear time. And then, depending on the new probabilities, you can see if some intrusion objective is expected to be compromised or not. So there are different situations. Either the new actions, the probability of intrusion objective decrease. If it decreases, then this means that the action has no influence, has even negative influence. It corresponds to what is called anti-correlations. For instance, if you have some actions, there are some actions in the systems assume that in some scenario, A1 is needed. Okay? Assume in some scenario, A1 is needed. The end user try to reach A1. Assume that someone, security operator for instance, has executed A0. When executing A0, the effect of A0 will give some value, some conditions, which definitely makes A1 not possible to be executed. I mean, the preconditions of A1 will be false. And this means that for this scenario cannot happen. I don't know if it's clear. It's called anti-correlations. Means that the A0 gives, as a post-conditions, a contradiction with precondition of A1. Hence, the execution of A1 will prevent, the execution of A0 done by some security operator will prevent I1 to be executed. This is what it means. So there are actions with positive influence. Then it depends if some tree holds, if it exceeds some thresholds or not. There is maybe some small changes or big changes. In the case where the threshold, the new probabilities exceed the thresholds, then this means that the probability to reach the intrusion objective exceeds the given thresholds, and hence the VN realistic, and some alerts should be produced. So I will explain this approach first on some illustrative examples. As you know, DARPA, especially since 1988, 1999, 2000, etc., has used some benchmarks for evaluating the systems. For instance, in DARPA 1998 is in fact the KDD, the challenge of KDD 99. It corresponds to the challenge of KDD 99. And DARPA 2000 is specially dataset benchmark is specially defined for complex attacks. The ability is how one can detect these complex attacks. And it concerns distributed denial service attack. It is based on very simple idea. There is a tool called SADMIN tool used by networks operators. And in this tool there is a problem, a buffer overflow problem. And the attacker simply try to see whether there is available host, whether there is available tool, and then use some actions in a sequence to compromise this host. Okay? Now, if the precondition and post, I was involved in the definition of precondition of postcondition of this. It took some time, but at the end we succeed. If it took some time because the set of action is not very high, it's just 11. So if you have 11 actions, you can action by action try to define how it works, what are conditions, you run it on different systems, and etc. So you will be able to define preconditions and you will be able to define postconditions. And at the end, we were able to detect the scenario that has been proposed here. Now this is the first approach. It took some time, but we succeed. Again, we succeed because the set of action is small, 11. It's not high. Now what we want, and this is the benefits of data mining, is that I have no information about the traffic. Okay, you give me just the traffic, and the only thing I require as expert knowledge is to say at what time the DDoS has been achieved. The only thing what we need is this for training. This is the only. Comparing to precondition, postcondition, we took each action, we define precondition, postcondition. Here, using data mining, the only thing that I require, I don't know even to understand what the meaning of the actions. The only thing we need, just let me know what this abnormal event happened. This abnormal event that a security operator would like to monitor, would like to follow, happened. This is the only thing. If you give me this information, I will be able to predict this scenario. And this is exactly what you show. So the first thing is to take this traffic, give it to some intrusion detection system like Snort, and when Snort execute, there are 11 actions that has been produced, the same action that has been produced.